number one, which of the following equation does not represent a linear relationship? So this goes back to our first lesson actually about linear relationship. So if you want to get out the notes, you can. So if you haven't downloaded it, it's very up top in the chat. Let me see if I can find it. Actually, you know what? I'll post it again. I'll post all the notes into the chat right now. So last time, listen, yeah. So that's the part about. So you can open that one, and then so I actually have the lessons labeled. So that was lesson 9, and then the last lesson we had was lesson 13. So we actually have been talking about this for 5 lessons now. And then that's the second session about a linear relationship. And then there's the third session. I know they're all called notes. Yeah, I should probably have better naming. But and then that's the fourth session. And that's the fifth session. Yeah, so those are all. Oh, no, not the homework. My bad. Delete message. This one. Yeah, so you can open up the notes as I'm going over the questions today. So this one, the first question is mainly about the first set of notes. And essentially, we want to find that it's not. So most of them are, that means 3 out of 4 of them are linear relationship. So linear relationship, right? It is degree of 1. So that means when you have x or y, they must have like the exponent must be 1. So not 2, not -1, not 1 over 2. So this one, well, this is just a y-intercept form. So, you know, I think this should be pretty familiar. So this one is definitely yes. And then this one. Well, actually, at first glance, it looks like that it is not. But remember about equation manipulation, you can actually simplify this a bit. If we divide x on both sides, what do we get? Y, so on the left side is y, y divided by x is y. And on the left side, you can actually divide this out. X squared divided by x is x, just x. So on the right side, you get 4x plus x divided by x is 1. So this is actually also a linear relationship. Now the third one here. So this one, although the x is seems to only have a 1, but now, so this goes back to exponent now. So everything is connected. So if you don't remember, when you have a variable in the bottom, the exponent is actually -1. So this is actually equal to 2 times 1 over x. So I just separated them. And when you have the variable in the bottom, you get 2 times x to the -1. Now for a linear relationship, you must have a degree of 1, and that does not include -1. So this one is actually no. And what about this one? This one is a standard form equation. And x, the exponent is 1, y, the exponent is 1. So this one is correct as well. So the answer to number 1 is actually C. It's not B. B looks like that. It has the exponent of 2 and it's not right. But when you simplify it, you actually get everything in degree 1. But for C, you have x in the bottom. And when you have x in the bottom, you actually don't have a degree 1. You have a degree of -1. I'll just highlight this. So C is the correct answer here. Any questions? Okay, take that as a no. So if you're doing a test in class, so an actual test, questions like this will usually be in multiple choice as well. So identifying linear relationships. Now fill in the blank. This is the second question. So the point of this question is to first recognize that, well, these equations, they are lines, right? We have been talking about lines of linear equations. So this here can be graphed as a line, this here can be a line, and this here can be a line. So the first thing so if you cannot recognize what the slope and all these are from the equation, first you have to graph the equations. I'll move this up a bit actually. So 2a. So let's look at 2a first. Now this should be this is in y-intercept form. So if you look at the original one, whereas y is equal to mx plus b, right? We talked about this a lot of times, how m is the slope and b is the y-intercept. So this means that you can actually just find the slope and the y-intercept pretty easily, just from this form. So the slope should be 2. So see, y-intercept form, m is the slope, m is 2 right here. And b, y-intercept. So y-intercept is a point, right? The point must have an x and y coordinate. So when the point is on the y-axis, the x value will be 0. And the y value, well, is the y-intercept, so that's 1. So the y-intercept of this line is 0, 1. What about the x-intercept? So our definition of x-intercept is where the line crosses the x-axis. That means the y-coordinate is 0, and the x-coordinate is wherever that line crosses the axis. So the y-coordinate is 0, so we set y is equal to 0. So we find the intercept, x-intercept. Find x-intercept by setting y equal to 0. So we solve for the equation. 0 is equal to 2x plus 1. So 2x is equal to negative 1. And therefore, so I minus 1 on both sides, x is equal to negative 1 over 2. So x-intercept, the x value is negative 1 over 2. And the y value, since it crossed the x-axis, is equal to 0. So let me graph it out. So how would it look like? So I have a graph here. So x-intercept, well, I'll grab the y-intercept, right? See why the x value is 0 now? It's right here, right? So whenever you have a y-intercept, it's always that the x value is 0 and the y value is whatever is here. So it's 1, so it's here. Now the slope is 2. That means when you go right 1, you go up 2. So there you go. Right 1, up 2. There's your point. So you can connect the points. So I'll connect mine like this. So the x-intercept is right on this point over here. So this is why the y value of the x-intercept is always 0. It's right on this point. And then the x value is whatever where it is. So this here is negative 1 over 2, as you can see. It's right between negative 1 and 0. So that is the x-intercept. So always remember, y-intercept is on this straight vertical line. So you have a y value, but the x value will be 0. And x-intercept is on the horizontal line. So it will have an x value, but it will have a y value of 0. So as seen here, x-intercept, no y value. Y-intercept, yes, y value, but no x value. So a point on this line. So I didn't specify which point, so actually you can use any of these two. So no correct, many correct answers, but I could actually just use this one. But you can use other ones as well, as long as they satisfy this equality. So as long as x, y satisfy the equality, no, equality, y is equal to 2x plus 1, xy is a point on this line. So let's say x is 3, then y will be equal to 7. So 3, 7 will be a point on this line. So you can write this as 3, 7. Because, so I plug the numbers in. So 3, 7, I guess 7 is equal to 2 times 3 plus 1. And 7 is indeed equal to 7. So the equality is satisfied. So 3, 7, x is 3, y is 7. That will be a point on the line. And yeah, another point. So if x is equal to negative 1, then y will also be equal to negative 1. And that will also be a point on the line. And you can see it right here actually. Negative 1 and 1 is, negative 1 and negative 1 is a point on this line. Right here. Because they satisfy this equality. When you plug y is equal to negative 1 in here, and x is equal to negative 1, the two sides will be equal. So that is 2a. Any questions? Questions. Going once. Going twice. No? Okay. So 2b. Switch the color. Maybe I'll do it here. So 9y minus 3x is equal to 4. Let me see. Yeah, right here. 9y minus 3x is equal to 4. Let me just make sure I got the equation correct. Yep. So this is in standard form. So when you have an equation in standard form, the easiest thing to find is the x and y intercept. So x-intercept is when the y value is 0. So we solve equation, same as last time. For when y is equal to 0. So always comes down to this. So on the horizontal line, so there's no y value, or the y value is 0. So what do we have? Now remember, when you have 0 minus 3x, that's not 3x, that's negative 3x. You got to remember the negative sign up front. So it changes the answer completely. So if you divide both sides by 3, you get x is equal to negative 4 over 3. Yeah, divide both sides by negative 3, I mean. So the x-intercept, remember, is a point. So it must have x and y value. So the x value is negative 4 over 3, and the y value is 0. So, and then we find the y-intercept using a similar method. So solve equation for when x is equal to 0. So x equal to 0, x equal to 0 is on this vertical line over here. So you will have a point on this line, and that will be the y-intercept. So this equation, so 9y, I'll do it, keep it consistent. Do it here. 9y minus 0 is equal to 4. So since it's 9y minus 0, then you get 9y. No negative sign here. And you divide both sides by 9. 4 over 9. Or you can say it's 0.4 repeating. That's okay as well. So, and then the y-intercept, of course, is a point. X value is 0, y value 4 over 9. So, this question, immediately you should be able to get these two, x-intercept and y-intercept. So x-intercept was negative 4 over 3 and 0, right? That's what we got. And then y-intercept is 0 and 4 over 9. And then side said any point on this line, so I could just choose the x-intercept. It is a point on the line. It's just special point, but it's still a point. So what about the slope? The slope is not that apparent at first. But what I want you to recognize here again is equation manipulation. So a lot of this is about equation manipulation. So remember, for y-intercept form, we can just directly say that the value in front of the x, what the x is multiplied by, is the slope. So if we can get it to y-intercept form, then we can find the slope. Any number in front of the x, that is the slope. So we can rearrange the equation a bit. 9y minus 3x is equal to 4. So if I add 3x on both sides, I get 9y is equal to 3x plus 4. And then, so y-intercept form. The y has a, so this is called coefficient. But yeah, just any number the y is multiplied by is 1. So in y-intercept form, that number is 1. So you want to divide 9 on both sides. So y, 3 divided by 9 is 1 over 3. So 1 over 3x plus 4 over 9. So 1 over 3 times x plus 4 over 9. That is the equation in y-intercept form. So remember, by equation manipulation, I didn't change the equality. So this equation is the same as this equation over here. Oh, I don't need to box the whole thing. I just need this because this is just the slope. That's all we care about when we manipulate it. And you can also see, right? The plus b is 4/9, and that is just matches what this is, your y-intercept. 4/9, 4/9, they're the same. And it should be the same because it's the same equation. So from y-intercept form, what we really care about is the slope, and slope is 1/3. So the answer to the first blank here is 1/3. Slope is not a point, it is just a value, so you don't have to put it in coordinate form. So there's that. Any questions about this, and this? Oh, hello, Olivia. Thank you for joining us. Yeah, so we're just going over the quiz, the entire quiz questions. That's what we'll be mainly doing today. So I'll give you a second to give everyone a second to take a look at this. And you can also take a look at number 1 as well. Give you a few minutes to digest. Yes. And there's your answers up there. I don't know if you can see it, but yeah, they're also here. So if this is okay, then let's move on to the third 2C. So, oh, I forgot to graph this, but it's actually not an easy graph to graph because you have a slope. No, the slope is easy. It's just you go across 3 and then you go up once. But the intercepts are pretty hard to graph. They're not whole numbers. But I can kind of sketch it. So just a rough sketch. So it's not as precise as the one from before. So x-intercept is, so if I graph only using these information, is not so easy. So -4/3, that's just over 1. So that's where the x-intercept is. And the y-intercept 4/9. Oh, that is somewhere around here. It's less than 1, less than 1/2. So if I connect the points, something like this. So you see, not a very rough sketch. So in order to make a decent sketch, what I can do is to find a point. So a point other than the x and y intercept on this line, right? So let's see if I can find a point, a whole number point. So y x 1, no, 2, 3, 27 minus. Ooh. Give me a sec. So to find a whole number point is actually using a bit more math, but that is, it's kind of complicated. But let me just try out some numbers. Oh, I think this graph actually does not have a whole number. So it does not have integer points, if I remember correctly. Yeah. So you see how this is a fraction and this is a whole number, but you cannot have a point that is whole number and whole number. Actually does not exist, I think. Yeah. Yep, yeah, it would not exist. So you can only briefly sketch it out to kind of get an idea of what it looks like. So x-intercept is -4/3 somewhere here, and then y-intercept is here. And you connect the 2 points, you kind of get this. And the slope is 1/3. So I'll move these 2 questions on the bottom. Oh, no. Ah, didn't select it all. So there. Put it down here. And then this one, I'll put it down here as well. So that we have space to do the okay, so that's 2A and 2B. So move on to 2C. So 2C here is in point slope form, right? So if you can change the color once more. So it's in y minus y1 is equal to the slope times x minus a point, where x and y are a point. So this here is essentially the point is 2 and -1. So x minus -1 is equal to x plus 1. So what you can get by first glance is a point. Because point slope form, you need a point, and the point is already in the equation. Two? No, 2 is the y value. So the x value is -1. And the y value is 2. So this should be your point. Point slope form is already in here. So this question was y minus 2 is equal to m. So m is 3. Oh, so there you go. M is the slope. Oh, I'm just writing it. So the slope is 3 for this graph. It's right here. M is 3. You know, when they're in the same place, they probably mean they are the same thing. So whatever takes the place of this, they represent the same thing. X minus, so since the eventual one was, the final form was x plus 1, so it's x minus -1. That's how you get a plus 1. So that is your, so that is how you got the slope and how you got this point. So how about the x-intercept and y-intercept? So again, same thing. Always the same thing when you do x and y-intercept. You set x-intercept, you set the y value as 0. So I don't need to change it into any form. Of course, it might be easier if you change it into a y-intercept form. If that helps you, then sure. But you actually don't need to. So x-intercept, y is equal to 0. So 0 minus 2 is equal to 3 times x plus 1. So -2 is equal to 3 times x plus 1. I probably want to multiply this out. So let me just multiply it out in this line. 3x plus 3. And then minus 3 on both sides. I get 3x is equal to negative 5 is equal to 3x. Same thing. And then the y3 on both sides. I get 3x is equal to negative 5 divided by 3. So that is the x-intercept. Oh no, that's not the x-intercept because it's a point. So you need it as a point. Y is equal to 0. So that is your x-intercept. So how about the y-intercept? Just simply set x is equal to 0, not y. So again, you don't need to change it. So if you change this into a y-intercept form, so manipulate it to change it into y-intercept form, then you will simply take the b value. That will be your y-intercept. But you don't really need to do that. You can just solve the equation directly from here. So 3 times x is 0 plus 1. So I'm just plugging in the value into here, this equation. So add 2 on both sides. And then 3 times 1 is just 1. 3. 3 times 1 is just 3. So 3 plus 2, y is equal to 5. So that's your y-intercept. 0 and 5. And there you go. So this y-intercept. So how do you graph this line? This line is easier to graph because you have a whole number value here. So first I have a point. The y-intercept is 0 and 5. So 1, 1, 2, 3, 4, 5. That is a point. And we know the slope value. The slope value is 3. That means you go right 1, you go up 3. And no more space there, so just here and here. And when I connect the points, I get this line. So that is the line. You don't need to graph it for this question, but I'm just graphing it for a visual aid. So, and right here is the x-intercept, right? So it's kind of to scale. So negative 5 over 3, that's a bit over 1, and it shows here. So this is negative 1, so a bit over negative 1, that is negative 5 over 3. So take a few seconds to look at the question, and if you have any concerns, type it into the chat. Okay. So I'll move this one down below as well. I'll post this note late after class today. Put it right here. So that's 1 and 2, the first 2 questions. And here are your answers. Now for number 3, going on to number 3. It was as I told some of you who said that the line is, they are not on the same line, these points are on the same line. So right now, first thing first, they are on the same line. But how do you check if they're on the same line? So the best way to check if is to, so these are 3 different points, right? So imagine you have so now these 3 points, they're not on the same line. So why are they not on the same line? Because if you draw the equation between the 2 lines, then, and then you can also draw the equation between these 2 points as well. They are different lines, so they all have different equations. But if you have 3 lines that are on the same, 3 points that are on the same line, then from this point to this point, you will have a line that's this, and from this point to this point, you have a line that's the same line. So if they are, so the best way to check if they are on the same line is to find the equation between any 2 points, well, between all pairs of points, and see if they are the same equation. If they are the same equation, then they must be on the same line. If they have different equations, that means they are not on the same line. So let me write this down. Between any 2 pairs of points. No, between pairs already by definition too. Any pair of points. So you get 3 pairs here, right? So this one and this one, this one and this one, and this one and this one. So you have 3 pairs. If all equations are equal, then the points must be on the same line. Otherwise, they are not on the same line. And in fact, if you find the equation between any 2 pairs of points, so say you find the equation between these 2 pairs, and you find the equation between these 2 pairs, and you find the equation between these 2 pairs, and they all end up to be the same equation, then you essentially already answered the last part of the question. What is the equation of that line? Well, it's just that equation that you have found out. But if you found like different equations, then automatically they don't belong on the same line. So your answer to this question would just be no. So let's go check. So first, let's check these 2 points. How do you find the equation between any 2 points? You need to use point-solve form. So line formed by, so the first pair that we can check is -4, -5, and -1 and -1. Now, remember, so we need to do a slope calculation first. Point slope form, we need a slope. Slope, we usually write y2 minus y1. Slope is the change in y over the change in x. So to have a change, you can only use 2 points. So let's say that you assume that they are on the same point, and that is a fair way to do it. You can assume they're on the same point, and you can eventually you might find out that they are not, or they are, your assumption is right or wrong. Doesn't matter, but you can make that assumption. But what you cannot do is calculate a slope from 3 points. Just because I gave you 3 points doesn't mean that you calculate the slope from the like the change, the total change. So like the total change between this point and this point is this, right? So this is the change in y. But let's say you use all these points in the slope calculation. So let's say you did a -5 minus -1 minus 7. If you use 3 points to do a slope calculation, you are essentially adding this. So you're adding this value. So this change, you add it to this change. So total, your total change between 3 points, say, if you do it this way, will actually be all the way over here. But all the way over here, this is not the change between the 3 points anymore. This is a different. And same thing as x. If you added this and this, then your total change is actually a bit more. So it's something like this. Now, how I drew it, it looks like it's still the same slope, but it's not. It's not the same slope. A slope is only between 2 points. You can only calculate a slope between 2 points. So just because I gave you 3 points, not 2, as I usually do, doesn't mean you use all the points in the slope calculation. You choose any 2 points to do a calculation. So the slope formed by these 2 points. Plug in the values. So let's say this is a y2. So -1 minus -5 over -1 minus -4. Slope is 4. And here, the slope is 3. So using point slope form, I can just pick any of the points here. So let's say I pick this point. Y minus -1 is equal to the slope times x minus -1. And you get y plus 1 is equal to 4 over 3 x plus 1. So it is a really good idea to simplify this down to y-intercept form, and you'll see why later on, but I'll just do it right now. So I minus 1 on both sides, and I expand the right side. So 4 over 3x plus 4 over 3 minus 1. And I get y is equal to 4 over 3x plus 1 over 3. Now, let's find another pair of points. Let's use -1, -1, and 5 and 7. So, yeah, we can use that.
So we do the same thing. So we find the slope first. That is equal to 7 minus -1 divided by 5 minus -1. This is equal to 8 minus 6. 8 divided by 6, my bad. And you can simplify this down to 4 divided by 3. So the slope matches. So that's a good sign. That means they could be on the same line. And then, so we find the equation using Point-Stokes form again. Now, so actually, you can already say that if I use this point and the slope, I would definitely get the same equation as this one, right? Because this is what I use as well, -1 and -1. So you can actually say that simply by this, they are already on the same line. But I'm just going to use the other one to, check, see if my first calculation is correct. So y minus 7 is equal to the slope times x minus 5. So the reason why I wanted to simplify, now it comes in, is because x plus 1 is equal to 4 divided by 3 times x plus 1. This equation and this equation is not very obvious at first glance. Rather, they are equal, right? Or not. But if you simplify into y-intercept form, you would definitely have it equal. You should definitely have it equal. So definitely should look the same. So again, I multiply out 4 over 3x minus 20 over 3, and then plus 7. Add 7 on both sides. So if I get a common denominator between this, so I can add them up, 21 divided by 3. Nope, not 1. 1 over 3. And there you go. We see that this one, they match. So actually, you only need to find 2, because we already utilize all 3 points, right? So we know that all 3 points have the same equation now. So you actually don't need to check it with the third pair of points. So you don't need to check it with -4, -5, and 5 and 7. Because if I graph this out, so I'll just do a quick sketch. So -4 and -5 is somewhere around here. And -1 and -1 is here. So I found the equation between this line. And it is, say it's a line like this. And then I also have a 5 and 7. So 5 and 7 is around, maybe around here, I think. Yeah. So the equation of this line is the same as the equation of this line. So automatically, the two lines are the same. So if you kind of graph it out, they are the same line. So you don't need to find between this point and this point, because you already made sure that they have the same slope, and then they all connect at -1 and -1. So they must be the same line. So yes, the answer is yes to this question. And the equation, as we found out twice now, is 4 over 3x plus 1 and 4 over 3x plus 1. So yes. And y is equal to 4 over 3x plus, oh no, plus 1 over 3, my bad, not plus 1. So that's all. I think one of you got really close to getting the right answer, but it kind of messed up on the slope. But that's okay, yeah. Good job. Oh, it's so small. You can't probably read it, right? So yeah, I'll post this after the lesson so you can take a look later. But essentially, you want to have the key is to find the equation of the line between a pair of points, and if they match, then they are equal. They are on the same line, and if they don't match, they're not. So that's number 3. Any question? Okay, so I'll move on to the last question now. So the last question, I gave you a just paste it here. I gave you a graph, and I want you to find the equation. Now, most of you found the equation y is equal to negative 2 over 5x plus 3. Normally, this is correct, but the key is to recognize this and this, these two. I switched up the axis. So this is correct if this is the y-axis and this is the x-axis. But it's not correct now because I switched up the axis. So this one you definitely won't see on a school test. This is a contest question, a contest type question. So, but I mean, it's all about finding the slope and finding the intercept, or finding. So you could either use. So here are your choices, right? It's always 3 choice. So y-intercept form or point slope form or standard form. So either one out of 3. That, or sometimes you might find all 3 helpful, or sometimes 2 of them helpful. But you must have at least one that is helpful to you. So by this, so if you look closely, the y-axis, y-intercept is not that clear where it is. So probably not y-intercept form. The point slope form, yes, probably, because we have 3 points. So you have 3 definite points that you can use. Standard form, not so much. So using point slope form, that is what I will use. So with point slope form, you need a slope. So what's the slope? Change in y over change in x. Always. So the slope So what's the change in y? So I gave you 3 points, so you can use any of them. I will use the blue one and the purple one. So the change in y, if I go down, so y right now is going down. It's going from positive to negative, so it's going down. So I go down 5. I go up. The x value go up 2. So the x is positive. Change in x is from a small number to a big number. But the change in y is from a big number to a small number. So change in y is negative 5. I went down 5. And change in x is positive 2, I think. Yes. Positive 2. So I went from 1 to 3. So 1, 2, 3. no, 2 and 3. So that's a 2, a change of 2. So that is your slope. The slope is always changing y over changing x. And that is what we got. So now you just need point slope form. So y minus y1 is equal to the slope times x minus x1. So I can use any of the 3 points. I am going to use this one. This one is -5 and -5. And it's a good idea to simplify it a bit, but this is actually all I need. You don't need to simplify it that much. No, this is all that you need.